Welcome. My name is Claus Isben, and you guys are here to hear talk about how to develop a cloud-ready Camel microservice. I'm a software engineer from Red Hat. I've been working with Camel for a long time. I wrote a couple of books on Camel. The second book is in what they call a pre-production. That means all the chapters are currently being proofed and tech-reviewed and revised. Then we expect that the book will be finished sometimes after the summer break. You can probably hear from my voice that English is not my first language. It's the second or maybe the third one. I'm based in Sweden. Well, not for long. Next month I am moving back to Denmark, which is my home country. So that's going to be good to get back home to my family and friends after 10 years there. I've been working in the IT industry for almost 20 years, and I guess I'm old. I at least got the hair for that. It's also officially, recently I got promoted to be a senior. So I'm a senior developer. But senior developer, you might be old, but in real life, I don't feel old. In the last 10 or so years, I actually probably has the best fitness level now. So 3 days ago, I completed a half marathon. It was a semi-trail, which means that the first part of it was, in the city with paved roads, and the last part was actually on the beach with wind and sand and dunes and single trails and all kind of things. So it was a tough one. But I'm happy that I completed it in about, under 2 hours. So maybe a goal could be to come back to Boston sometimes and do the complete marathon. That would be awesome. Okay, well, this is not a talk about me. You're not here to hear that. You're here to see something else. So what is the goal of this talk? I guess how many people here are developers in the cloud? Okay, great, you're in the right room. So this talk is for you guys. It's for Java developers or Camel developers, but you don't have to been using Camel, but Java at least. So how can we as a Java developers getting starting with this new world with cloud and containers? How can we get our Java application cloud ready using containers, and how can we build some container image and take these container images and run in a cloud cluster such as OpenShift or Kubernetes. And when you start working with the cloud, there's a whole lot of new things to learn. It's sort of like what in this talk we're only seeing the top of the iceberg, talking about how to get your Camel application running in the cluster, and how that dynamic platform might affect you, how your applications are communicating internally, and so on. But there's a whole lot of things going on underneath. As a developers, we need to be aware of. At the end of the presentation, there are some slides where I give reference for more information. Okay. So I like, as a developer, this idea that there's a cursor blinking. So me, as a developer, I somehow have a control of that. I can always do something. So if you get started, developing with the cloud, you might think, okay, I have to go to my boss or get to some system administrators, and they have to set up some sort of cluster within the company, and I have to wait for that. I have to get some credentials to log in, and maybe I don't have the rights, and all that kind of things take time. And also maybe I'll screw it up so somebody can, I'll fuck it up for someone else, and beep. So I like that control, okay, but could I maybe just try on my computer, on my laptop? So this is what I'm going to do here. It's all running on this laptop, this old one. It's a MacBook Air, so 8 gig of memory, an old CPU with 2 cores. So actually, I'm out for renewal, so I'll get a new laptop later this year when I get back to Denmark. So what I'm saying is that if I can run it on this one, you guys can definitely run on your computers. So how can I run a Kubernetes or OpenShift cluster locally on a computer? Well, for OpenShift, we can use Minishift or the OpenShift CDK. I am going to use the Minishift, which I like. It's similar to upstream in the Kubernetes project. There's something called a minikube. So how do you run Minishift? You can go to the OpenShift website. There's a link for Minishift. You can also find it upstream in GitHub. There's a binary you can download for Windows and Linux and Mac and so on. And there's also detailed instruction how to run it, because you actually need some sort of a hyper virtualization layer as well. So besides running Minishift, depending on whether you're running Windows and so on, you need to install some software like Hyper-V for Windows or Xhyve for Mac and so on. But having done these steps, you can actually run it locally. Now it happens that Minishift and OpenShift are released independently sometimes. So it can sometimes be a good idea to say that, okay, I'm running Minishift, but I want to specify the exact version of the OpenShift I'm going to run. Because maybe there's a newer version, and when Minishift was released, so it's actually not using the latest one. So I can specify Minishift start and then exact the version. Or you can log it down. For example, your organization, your employer is using 1.5.0, and maybe you're not supposed to use 1.5.2 or 1.6 or something like that. So you can log it down to a specific version. Okay, and that's it. So you just run it from a shell, and you have it up and running. Hopefully. So one of the things you might want to do first after running Minishift is to see the web console. So you can just type Minishift console on the shell, and it opens up the web console. So just let me do that quickly. So here I have Minishift running. I can type Minishift status, and you can see it says running up in the top. And Minishift has a number of options or commands you can execute. You can see it there. But just Minishift console takes you, and you can log into the Minishift cluster. By default, you get a little product called My Product, so you have one out of the box. Now I click that one, and it shows the OpenShift Web Console, where we can see inside the cluster what is running. And this is all running on my computer. And there's something running already, and that's because I already prepared a little demo, which we're going to talk about. So there's something called Hello Swarm running with one pod. But the idea is that you can always go and look for your builds and your deployments and service and so on and so on. Anyway, just want to show you, this is how you can access the WebShift console. Now, in addition to when you run the Minishift or cluster, is that you might want to have some additional commands on the command line. And up here in this dialog button here, there's something called command line tools. You can click that one, and it gives you instruction how you can actually download and install these ones. And what these command line tools allows you to do, just do it quickly, is to use a command called OC, OpenShift command line, and get. And you can get a lot of resources from the cluster, and one of them is called a pod, which is the running containers. And it can show you a full list of pods, and they have different states. Some has been completed, and some are running, and so on and so on. Anyway, this is just, as a developer, it's all running on a computer. You have the web console, you have the Minishift command line, and you have the OpenShift command line, all running locally. And we are back to the slides. Okay, so now let's start building let's get some Java code running on this cluster and see how to do that. So what we're going to do is to build a little Camel microservice and build it locally so it can actually run without the cluster, and then see what we need to do in addition to get it running inside that cluster, and then run it and then have some fun and see some of the things that are actually different when running in a dynamic platform versus running it in a static environment. And okay, so let's build something with Camel. Mr. Camel always use Camel. It's good and bad. And this Camel is actually built by Lego bricks. And Lego, the company is from Denmark, so this is a beautiful Camel. We all see in Lego in Denmark. So the source code and the slides for this talk is online on GitHub on my account, Klaus, and then Minishift/hello. So we're going to build a very simple Camel application, a little service, a hello service. Hello world is always good, or maybe hello Boston, could it be? So we have a service over here, and a client that want to call the service, and the response from the service is something that includes the host name where the service runs. And of course, we're going to use that so we can see sort of like this dynamic environment where the response is supposed to be different. Even though I'm using Camel here, is some of the tools and all that kind of things works for any kind of Java framework or library. So if you're not using Camel, even though you probably should use Camel, it's possible anyway. So for the application, we're going to use some popular runtime containers or popular Java containers, if you will, Spring Boot and WildFly Swarm. So it just happened to be that WildFly Swarm is hosting the hello service, and Spring Boot is going to be the client. It's possible to reverse them. There's no restriction in Camel and so on. And for communication, we're going to use HTTP. That's something everybody can use. So we put Camel inside those two. So on the blue side, the WildFly Swarm, we're going to use a Camel route that says from underTOF. And underTOF is the HTTP server that comes out of the box in WildFly Swarm. So we're going to use that. So we tap into that one. And then we do a message transformation where we're going to return that host name. The client side is the Spring Boot one. We don't want to do anything by manual. So we just want to use that timer. So every time, every 2 seconds, we're going to call that service and log the response. So that's a very simple route from timer to HTTP and log. And you can build these from scratch, easily with WildFly Swarm. There's a website called WildFly Swarm Generator. You can find it on the wildflyswarm.io website. There's a generator button. You can pick up your dependencies and then give a little project name, and then there's a button to download a zip file which has this sort of pre-created project for you. It's a nice little tool to do that. And I did that already. I created 2 classes. One is the Camel route. Hello route is a CDI singleton. I have the route down here with from underTOF, and then we're going to do a message transformation by calling a Java bean. So it's just one line of code in Camel. And the underTOF endpoint and the Java bean has both been dependency injection. I actually have a marker here. The Java bean that's going to return that response is very simple. It's just a single method say hello. Swarm says hello from, and then something that grabs the host name. Right, very simple. On the client side, we can do the same thing. Spring Boot also have a website called startspring.io. You can choose your dependencies and Apache Camel and all the great stuff in there. You can do that. And just by the way, I also chose something called Actuator and Web in the client side. And the reason for that is going to be later in the talk when I'm going to show a bit about when running in a container, you need some sort of health check and whatnot. The Actuator is the Spring Boot way of having health checks, just observation. WildFly Swarm has the similar thing with the monitor things. The client is very simple. It's just a Camel route from timer to HTTP and log it, right? Anybody here use IntelliJ IDEA as the tool? Okay, 10 or so. Well, maybe you should try it. Have you seen out there, there's a little camel icon. You get that from IntelliJ. So what we have here is, I installed a little plugin inside IntelliJ called Apache Camel IntelliJ plugin that gives you some smarts inside your editor. So let's suppose I am defining a timer endpoint, foo, and then the question mark here. I'm not sure you guys can see it in the back, but when you code in Java, you can press Control Space and get a lot of things. Now you can get the same for the Camel options you can configure on the endpoints. So here's a list of all those. And you might see some are bold and some are not bold. So the bold ones are the, let's say, the more commonly used, and the non-so-bold is the more advanced, obscure ones. So I can go and look at all these ones. And then I can press Control J, and you get the documentation down here. Now, because this is a presentation mode in IDEA, so it shrinks everything. But if you have a normal display, this one will be bigger, and you can see it immediately. But the idea is that you can actually, it changes while I scroll. So I can actually read about all these options going up and down, see the default values and so on. And this is based on all the Camel components you have. It also knows about, if you're familiar with Camel, an endpoint can be in consumer or a producer side. And the list here is filtered based on which side are you doing. So it's quite smart. So I'm going to use the period. I can need to specify the period. And now it says, OK, I need to enter a value. Control space, it shows me the default value also. It was 1,000. Let me use 2,000 instead. And that's it. And so on and so on. And you can also press Control J on the entire line. So let me do this a little bigger. This is hard. Jesus, sorry. I'm old. But the idea is that you can go and look at all the Camel endpoints, press Control Space, and it shows you how it was configured on all these options that were in that endpoint with their options and their documentation. So you get that it's only relevant for that endpoint instead of going to look at a big website. Now, if you want to see the Camel documentation for this endpoint, Shift F1. It opens up in the web browser on GitHub and see this is the documentation for that one. You can go and read it here with all these options and blah, 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 blah. So you get sort of like that at your fingertips. The tooling can do a bit more, but that's it. There's only 10 people using IntelliJ. Now, can this be done from Eclipse as well? Yes, in the future as well. There's an Eclipse plugin for Camel, but it's currently probably a bit too focused on drag and drop, the graphical things, but we will also like to have it being able to have the same smart completeness here, as you see. OK. That one. OK, so this little application, if I built this, I could run it locally, on 2 different JVMs, but I need to run it in this container cloud thing. So this is where we have to pay attention what comes next. How can we actually get this stuff from my laptop running in that cloud? So how can I take some Java product that is a Maven-based and build that as a Docker image? OK. And I want it to be easy, right? So what you can use is a plugin from the Fabricate upstream product called Fabricate Maven plugin. Now, there is actually also a plugin called Docker Maven plugin. You can use that, but it can only build Docker image. The Fabricate Maven plugin is an extension to the Docker Maven plugin that also knows about Kubernetes and OpenShift and all these kind of things. So you get 2 for 1. So you might just want to use the Fabricate Maven plugin. But there is a pure Docker one if you want to go for that one. So it has a build goal, so you can actually just add this plugin and run the build goal, and we'll build a Docker image for you. So what is the plugin? It's just a Maven plugin. You add it to your POM file. But now, I'm not sure if you guys remember how to add a plugin in a Maven POM file. What I do is usually have to Google it or find some existing product and find their POM file and copy-paste and so all kind of things. So what you can do with the Fabricate plugin is to type this long command. This is actually standard Maven. So in any POM file, you can run any Maven goal if you specify its fully qualified name. So you can use the group ID io.fabricate. The artifact name is fabricate-maven plugin, and then colon and the version number, and then we have a setup goal. So the setup goal is able to add itself to your POM file. So you just run this command, and it gets the blob. Now, the setup goal is by default adding this one, but it has some smarts. So it is able to detect, okay, is this a Camel product? Is this Spring Boot? Is this WildFly Swarm? Is this WordX? And so on and so on. So in the future, there will be addition. So it can sort of adapt to your product, if so to speak. Now, with this plugin added to the products, I could, from the command line, run this fabricate build, and it will build those Docker image. In interest of time, what are we on? Yes. In interest of time, I will go a bit further in the slides, and then we're going to do this a bit later, right? So I'm just going to say that the plugin is able to detect that if you're running in OpenShift or if you're running in Kubernetes. Because in OpenShift, there's this notion called source to image. So what it's able to do is to actually build the product using OpenShift source to image. So you don't actually need to have Docker running and installed on your computer. And it outputs on the command line the build log as well. So you have that at your fingertips. And you can go and see it in the web console as well. But again, we're going to see that in a moment. Yes. Also, when you build, run Minishift, you can actually also, under the hood, use the Docker CLI. If anybody had been using Docker before with the CLI, you can actually tell Minishift to actually allow you to run the Docker command. So you can actually use the Docker command. So there's a Docker image command, and it just shows you the Docker image from the Minishift Docker repository. So it is Docker image. There's no magic. OK, so now let's suppose we did that. So we have those two Docker images, but we're just taking the standard code we built, and we haven't really thought about cloud native. What does that mean, you know? So when we have a service over here and a client that want to call a service, in the traditional platform, that was a more static environment. And now we go to a cloud environment where everything is more elastic and dynamic. So we have this static versus dynamic platform. And this is where developers, we have to pay attention. So we cannot go around using localhost anymore, and 8080 typical one. So we have to do something else. So the client is going to call a service in the cluster, but you can't call localhost 8080 anymore. We have to use something else. And what do we have to do? Well, we have to use something called a Kubernetes service. Okay? So what is that? Well, and what's the reason for that? So in a dynamic platform, your applications can actually be running, so to speak, anywhere. In an OpenShift environment or Kubernetes environment, they run in something called a pod, which is the minimum deployment unit inside the cluster that runs it. So inside that pod, you can have your service ordering. But the cluster can actually scale them up and run multiple pods. So now the client, there's two pods running that same service. And how should I know about that? And which should I call and so on? I cannot use localhost 8080, but now there are two pods. Which should I choose and so on? And that's where the Kubernetes service come into the picture. It's this sort of like in between. And then, the service knows what to do. So what is this Kubernetes service then? Well, it's a static. So the Kubernetes service is static in the sense that it's actually a virtual IP and port number in the cluster that is assigned and created once. So that service has the same IP and port number for the entire lifecycle of that service. Whereas all these pods and clients and so on, they run using a dynamic IP number. For example, in a data center, you can have a rack with a number of nodes running, and they're running these pods with your workloads, and that node might crash, and then the cluster detects that, and then it spin up pods somewhere else. So all these pods are actually dynamic. They can scale up and scale down and so on. So that's the dynamic part. But the service, the brilliant thing with the community service is that it's static. So you just need to know the IP and the port number once, and you can use the same IP and port number to call that service forever, regardless where the pods that host the service are running. And that's the brilliant thing about the Kubernetes service. So that is something as a Java developer you need to be aware of. Okay, when we need to communicate with our Java application or what else that runs in the cluster, we are using the Kubernetes service. And Kubernetes service is not some magic library I have to add to my Java program or .NET code or something else. No, it's just a network IP and port number. And this is something every programming language has out of the box. So here's a sort of illustrating what happens when you deploy this WildFly Swarm application that has the Hello service. So inside that, we have the Hello service. Then when it's deployed, that service is enlisted or registered inside the Kubernetes master. That Kubernetes master then propagates all the service changes that are going on in the cluster to all the existing running nodes. And inside those running nodes, there's sort of like a little daemon running. It's called a kube proxy. And that kube proxy listen and get these service changes. So the kube proxy knows everything in the cluster where all the services currently are running. Now, when the client is going to call the service and it has this static IP and port number, it may think that it's actually calling some sort of node running somewhere with that IP and port number. But no, there's some sort of IP table network magic, whatever going on. As a developer, I'm not sure how they made it, but it's pretty awesome. So it ends up actually calling this local kube proxy. And the kube proxy now knows, OK, you want to call this service. I know where they are. I'm cool. I'll do that for you. Just relax. I call the service, get the response, and give it back. Now, the kube proxy is also able to load balance between if you have multiple pods running the same service, so the kube proxy can actually choose for you. And now it does that by default in a not round robin, but hold on, in a random way. So that's the best thing. You know, the guys that created this stuff, the Google and the other Red Hat, they first created it using round robin, but they found out, okay, it's actually better just to do random. So if you start working with that, then you might think it goes 1, 2, 1, 2, but no, sometimes it goes 2, 2, 2, 1. But anyway, from you guys as the developers, all you need to know, okay, I need to call a Kubernetes service, and that service is just an IP and a port number. That's it. No more. No Java libraries, whatnot. Even though, said that, if you need a client-side load balancing based on some more smarter algorithm and so on, it's of course possible. You could decide for yourself which pod to run and call and so on. But out of the box, that's fine. You know, just use the static IP and port. But how do I do that? How do I do that as a Java developer? You do it. Well, Kubernetes, when it starts a pod, the containers inside that pod, they all get all the service injected using environmental variables. And hold on, you might think, what the hell is going on here? Why is that? Well, actually, OS environmental variables is something that any programming language on the planet is able to read and understand. So the Java code, there's no Java library needed. You just look up, okay, this is the name of the service, and then there are two environmental variables called service host and service port. And then you get the IP number and the port number. Okay, that's one way. That was the original way of doing it. But you know, after a while, they are also allowed to use service discovery or call a service using a DNS host name, which is also a good way to do it. But Camel has been around before Kubernetes. So when this one came out with the environmental variables, we made it possible in Camel to make it easy to use that from your Camel routes. So just use this double squiggly service :name, and then it calls that service. And if you want to use the DNS naming, then it's actually feels a bit naughty because now you can actually start to hard code that in your code. Just the service name is the host name and the port number of the service. Now, the port number, you might think, okay, is that dynamic? No, because when you define the service, the guy that creates the service, he gives it a name, but the exposed, he can also choose freely a port number. So actually everything can be agreed upon up front. So we can create a service called bar, and you can tell the port number is 1234. Okay, I can code that in and I can call you. Awesome. So by making these changes in my Camel application, and I am ready, I'm cloud ready, so to speak, or at least I am somewhat cloud ready. So how do I take my Java code and run inside the cluster? I guess you have guessed it. It's again this guy, the Fabricate Maven plugin. It has a deploy goal. So basically I just call Maven deploy and it runs in the cluster. So what I can do is to do that on the WildFly Swarm application that has the service and then on the client. Now this one I already run. This is already running on my Minikube, but the next guy is not running. So this is the guy. This is where we're going to go back to the live demo and do some stuff. Escape, back here. So I'm in the client. I can type Maven, Fabric 8, deploy. And now it runs. So it hooks into the Maven lifecycle and does a build and package and all kind of things and start to deploy it. And if we are really, really fast, we can actually also go and see inside the web console builds. You can see here is something running on the client is build number 13. I can go and look the build log if I want to do. This one comes also from the command line. The command line is actually a bit further. I think the build is finished. So the application is already being deployed. And if I go over here, you can see up here, the first one is the client. There's a circle of 1, and it's sort of like a light blue one. And the reason for that is something we're going to talk about in a second. And down here, that's the second one running. This is the one I already have been running for a while. And the light blue is still waiting, so maybe there's something wrong with the computer. I'm not sure, but let's just give it a little moment. And I said this is a 4-year-old computer, so it's not so fast. So now it became blue. So I'll give a hint. Well, we'll get back to that why it was not blue immediately and why it took a little while. But anyway, if we go back, the client is now running. And it's supposed to call this Hello Swarm service. But let me just try to call it manually from my web browser so we can see how that's possible. So down here, the service is here. I can look at this as the service I'm going to call. And down here, you can see the port mappings and so on, 8080. And this is the internal port number, so it just happens to be the same. This is quite common to do, but you can choose different. But here you can see host name. This allows me from my host operating system to call inside the Minishift cluster and call that service using a sort of like a DNS name. So I click that one and call it up in the top here, but now I get a 404 not found. And the reason for that is because the camel route is not listening on the root, it's listening on /hello. So if I type /hello, it says Swarm says hello from, and then the host name. I guess maybe you guys can't read in the back, but that's the point. So that kind of works. But we can also go here with the command line and say OC get pods. I can see them running here. And what I'm going to do is to tail the log from the client, this guy. I could OC logs follow, and then the client name. And now you can say here Swarm says hello from, and then there's some host name down. So let's try to see what happens in this dynamic environment when we can scale up and scale down and kill some stuff and whatnot, because we also need to build resilient applications, right? So I can go here in the web console under the overview, and I can scale up this one. Now it's scaling up to 2, and you can see now it's already running. So there's supposed to be 2, and let's go and look here. And oops, Jesus, damn, something's wrong. Did Mr. Camel make a mistake? Oh, I'm making a lot of mistakes. But hey, now it's working. Or maybe it's not. Yes, so now you can probably see there's like 2 different host names, and they're coming with different, not in random order. Okay, but why was there an error? Okay, so, and this is actually on purpose. So as a developer in Java, when we run is this dynamic platform, we have to cater for distributed application, and failures can happen, and they will happen. So we need to be able to deal with that. So failures can happen while we call a service, even inside this awesome cluster of OpenShift and Kubernetes. They can still happen, so we need to deal them on the client side. Now, on the server side, which is hosting the service, is there something also we can do so when clients want to call us, they can do that in a more resilient way? Yes, there is. So there's something on both sides we need to be aware of as a developer. One is sort of like, how can we retry calling the service on the client side? There are different ways of doing that. On the server side that hosts the service, we need to use something as a health check or readiness check to ensure that when we boot up our pod, it's running with Java, and Java takes a little while to start up. And while it does that, the cluster is not allowed to sort of say that this pod is ready and start sending traffic to it ahead of time. So on the server side, so to speak, we need to have some sort of mechanism that tells the cluster when you are ready. And only when I'm ready, you can call me. So that's the server side. And in this example, on the server side, I was scaling up one pod from 1 to 2. And on the client failed sometime, but then it works. But we don't want these failures. And one of the ways we can fix that on the server side is to add these readiness checks. So this is something you need to do as a developer. Now, the Fabricate Maven plugin is able to do that. Can detect what projects you're using. Are you using Spring Boot, Tomcat, or WildFly, and so on? But unfortunately, it happens to be that the latest release has a bug, so it fails for the WildFlies. So that's why the WildFly Swarm will fail, but the Spring Boot works. And if we go and look here, the OpenShift Web Console has actually also detected that. It says that Hello Swarm has containers without health checks. This is not a good thing, And you can actually, from the Web Console, manually add these health checks if you want. But, we don't want to have a deployment scenario where your administrators has to manually do things. So, you should come to a way where you actually can specify these health checks and readiness checks as part of your development effort or build pipeline system. Anyway, you can add them manually, yeah. But again, on the client side, something failed. Is there a way to fix that? And there is. So let's go and go a little further in the slides. Scaling up, yes, we saw those 2 none. So on the client side, we can use retries, or in Camel we call it redeliveries. So when a Camel or a client attempts to call a service, a common solution could be to use this, just retry. Okay, I called the service, it failed. Okay, I wait a second, I call it again, and it failed, and so on and so on. And suddenly, yes, now it works, right? That's a good thing. We can do that. So just show you a bit of code how to do that. 12.8. So in Camel, you can easily do that by these 3 lines of code, for example. You can add an exception handler to say any kind of exception happens. I want to do maximum X number of redeliveries, 10, 25, whatever, and in between I wait a second. So I can do this and build and deploy that. But I'm sure if we got the full time for that. No, but from the command line, I could just run this fabricate deploy, and it will do that. But there's a problem with this. There can be a problem with this retry thing, because at a certain time you got to stop running. You can't just retry forever, right? Also, another problem is that you can get this effect where suppose all the clients is retrying every service call they have, and then downstream there's some service that are really struggling. Every client in the end ends up calling me, and then it's cascading down, and this is what they call a thundering herd problem. So you just no, don't call me. So is there maybe a different way of doing this? And yes, there is. There is another kind of client-side failure pattern, which is called the circuit breaker. The circuit breaker is inspired from the real world, where you have this electricity thing in the fuses, so it can be sort of like a spike going on, and it can detect that, and it can sort of open, so the currency can't go through. But when you start working with the circuit breaker, you might think open is good and close is bad, but it's sort of the reverse here. So the green one, that is where everything works. So the circuit breaker is closed. That means there's no tap going up, so all the service calls go through. That's fine. Now we start to getting some errors, and you can configure the service breaker to sort of have like a threshold for how many errors in a certain rolling sliding window should there be before I actually consider that this downstream service is failing and I open. Now, maybe you don't want to do that in the first failure, but maybe only if 50% fails in the last 5 seconds or something like that. But there's a lot of configuration you can do that. But then it opens up, and when you open up, you have sort of like a fast failure mode. We don't really call the service, but you do some alternative. Maybe you have a default thing you can do. And then after a while, you might send one through. Okay, maybe now it works, maybe. So I just let one service call go through, and if it sort of still fails, okay, yeah, this downstream service is really struggling. I don't want to call it still, so you just keep on being open. And okay, maybe after a while, some of them are starting working. Oh, maybe so I'm now in a half open state. So maybe it's good, maybe it's bad, And then after a while, if all these start to work, I'm closed and everybody's happy. So this is sort of like a traffic light with the 3 colors, green, yellow, red. This is a good pattern, and the Netflix company created a popular implementation of that pattern called Hystrix. Camel integrates with Hystrix. So in the Camel route, you just say Hystrix, then you have a block in your Camel route, which is protected by this circuit breaker thing. Under the hood, it's actually executed as a Hystrix command. And then you allow you to do this on fallback if you want. So instead of calling the service, you can say, nobody want to talk to me or something like that. So we can implement that in the Camel code. So I'm go up here. Summit CD client, Maven fabricate. I'm just going to undeploy the old client because they are different names, they're separated. And just to show you a different thing, now I'm typing, I need an 8. It's not the first one, fabricate run. So the run command is actually doing a deployment, but it's doing that in the foreground as if it's running locally on your laptop. So if you're like running Spring Boot run or WildFly Swarm run or Tomcat run or something like that, but in reality, it's actually deploying inside the real cluster and all that kind of things, but it just tails the log and present it to you in the foreground. So you see that. So you have the impression that it's actually running locally on your laptop in the host operating system. And then when you press Control-C, it actually terminates undeployed everything. So it's sort of like a quick way of trying something and seeing in the foreground. Now it takes a little while to boot up because my computer is a bit slow still. but you can see here it tails the log. Yeah. Yes, so I'm just going to go to a different terminal and just see. See, we have 2 swarms, right? So let's just try to be evil and scale 1 down to 1. So there's only 1 of them running. So there's only 1 swarm. And then over here, you can see it's calling it. But now let's just try to kill that swarm. Hello swarm, OC, delete, pod. So this is a way of testing your resilient application. So now the pod was deleted, and now it says nobody wants to talk to me because there's no running service with that one. You know, the Hystrix breaker is open, and it catches those and does the fallback. And when the pod is coming up and being ready again, we should see traffic go through, and it's executing that one. Now you can see the response comes back online here. So that's a way of building resilient application. One thing I probably should have shown you, but you can actually also, the run command, there's a variation of that. You can debug as well. It's pretty cool. So you can actually run something with the debug goal. Then it actually opens up a tunnel port on 5005, which is sort of like the Maven debug remote port. So you can go in your editor and configure that as if it's running on local with 5005. And then you can set your breakpoints in your Java source code, and it hits the cluster and whatnot, and you can debug and so on. So it allows you as a developer experience as if it's running locally, which you're used to do, but it runs in the real cluster with the same kind of tooling you're used to. But we are running out of time. These are some of the OpenShift commands you can run from the command line that gives you some information about the different resources, which are good. This is the long command. If you want to call a service from my host operating system, and if I want to get the URL or something from the command line, you can run Minishift, OpenShift, service, the name of the service, -n, which is the name of the product. It's a long way, but it gives you that service. Okay, so the key message is how can we, as a Java developer or Camel developers, if you will, take our existing Java product, whether it's new or old, and how can we actually get those container ready or cloud ready. And we can use some Maven tooling that can build these container images for us. It can adapt to OpenShift source to image if you want, or Kubernetes local build with using Docker daemon. And how can we take these container images and run in the cluster? You can use Minishift and Minikube, and fabricate command can just use deploy and goal and whatnot. This is the sort of like, for Java developers who are used to using Maven, then you can still using Maven. You don't have to learn about these OC commands and kube commands and the Maven. I haven't even, does anybody even see the Kubernetes or OpenShift manifest files? So behind the scenes, when you deploy in the cluster, you have this huge YAML file or JSON file with all the description, what to do, and so on. If you have to write these by hand, it's really hard. It's getting hard. There's a lot of things. The Fabricate plugin generates that for you. And there's a lot of ways you can sort of augment that if you need different things. But out of the box, it has good defaults with ready health checks and so on. But if you want to change something, you can actually influence that. There are different levels of doing that. But you can use the POM file and do stuff. Or you can sort of have like overlay files where you can sort of have few things you want to overlay in the generated file and so on. So it's fully customized. You're not locked down in that environment if you really will use this tool. That iceberg I talked about is only tipping the top of the iceberg. There's a lot of things to concept. You can't read the slide on. I can't even read it here on a laptop, even if I have glasses on. But this is, when you download the slides, you can just see some of the concepts. Stateful jobs and service and all kind of things, CI/CD and whatnot. Some good books. Christian Poster wrote a really good book called Microservices for Java Developers. It's free for download. There's an also very good book called OpenShift for Developers by Grant and Graham. It's also a nice one. It's focused on Java developers as well, and they are free. And then the not-so-free book, Camel in Action. This is where you guys are gonna pay up. So there's a discount code called Camel 39. It gives you 39%. And yes, you can try Camel 100. Unfortunately, that doesn't work. But you can try from maybe 99, 98, 97, you know. I know this one works kind of forever. You know, sometimes the publisher gives us a special rate discount, and it only works for 2 weeks or so, and then we have to ask them all the time for a new one. But that can sometimes be 50%. But yeah, and it's going to be a big book. So I guess, you know, yeah, if you have some desks that really need to be elevated, we're talking about 8, 9, 1,000 maybe. So Camel is a very lightweight product, integration library, but to understand it, you know, that's a huge information. Okay, this is a blueprint of Starship Enterprise. No, it's an exhibition hall. So I will be down there tomorrow for a boot duty, me and Christian, from 3 to 5 at the developer community central, where you can catch me and ask questions. I'll also be around, of course, for the entire event. I'll fly back on Friday. And I love to chat, and I like coffee and beers and all that kind of things. And tomorrow I'm even going for a run, for the 5 km run, and maybe for the baseball game, but I'm not sure if there's seat available. Some links, Minishift, the Fabricate Maven tooling, and the slides. That was Claus, Minishift, hello. Okay, I guess this lunch now, but any questions?
Is WildFly Swarm going to be productized anytime soon?
So the question is WildFly Swarm going to be productized anytime soon? Okay, so I'm a developer without.
I love WildFly Swarm.
Yes, me too. It's one of the Spring Boot and WildFly Swarm. That's why they're here. So yes, it's going to be productized. There is. I only know the name by upstream name. It's called Obsidian Toaster, but it's in part of that, it's going to be productized. One more question.
Can we use Fabricate for production deployment? What is the best way to deploy apps in production?
So the question is, can we use Fabricate for production deployment? Okay, that's a quite open-ended discussion. You know, if you attended next door, there has a full day about developer experience when the Fabricate team is in there. Fabricate is the upstream community product. It's the producting is OpenShift. So the good parts of Fabricate are part of OpenShift. So that's where I recommend, because upstream is a bit a lot of things going on. So it's maybe not always as stable as you want it. Okay, I guess it's lunchtime. Any more questions?
Well, I have kind of an open-ended one that you might want to take aside.
Okay, yeah, we can do that.
The browser just is, and why should I do it? I've not found a good selling point to get Camel in there.
Okay, yeah, that's a good question. So Camel allows you to define camel routes in XML and Java code, and you can change them easily between one and the other. And so the company wants to use XML, but the developers are using Java, and the Java guys are actually going offstream and not using Camel. They can just using their APIs directly. Yes, you could do that because it's all Java code, but then you need to write a lot of code by yourself. Maybe for XMQ it's not as much because it's DMS API, but you're still logged into that. If you use Camel, it's very easy to switch the endpoint and configure them. You saw that tooling. It's very easy just for DMS, and if you want to use AMQP, you just change that to AMQ endpoint and do a few other configurations, and suddenly now you're exchanging messaging using AMQ instead of DMS. Yeah, well, there's not, well, no, there's no public, I guess, for that. You know, every sort of performance test or measurement it varies between who performs them and your setting and so on. But we usually say that Camel overhead is low because most of the work is I/O network things and so on. That's where Camel is actually very adaptive because it can run in different modes, synchronous and asynchronous and non-blocking and so on. So the overhead is a limit. If you really want to be very specific about it, you can actually tweak Camel to turn off functionalities. So if you may have critical parts, you run it really fast, turn that off. But yeah, so, but normally you can't really measure that normally, you know.
No, yeah, I understand. I mean, I started trying to push it in through JBoss fusions or, service mix. Back when it started out, it was called service mix.
Yeah.
And
Maybe we can take it offline, or the lady sitting next to you, Ms. Jealous, he can also probably help you with some reference. Okay, thank you for your time. It's lunch now, and.